Good morning. Welcome to Portland 251. Today we have an entire stream of HTTP talks. First up, we have Dave Callahan, who's going to be talking about the new mobile web service worker, push, and app manifest. Please welcome Phil. Welcome.
Thank you. So we're starting a little late, so I'm going to try to move and make up for some of that time. We may not have time for Q&A at the end, but if you want to talk more about this topic or pick up some Firefox stickers, I'll just congregate right outside the hall once we're done. So this year continues a long tradition of me coming to PyCon and giving talks that are at best tangentially related to Python. But this year kind of marks a new low in that I'm not actually talking about the new mobile web. On the upside, this is like clickbait for conference organizers and conference attendees, so thank you all for coming today. Instead of the new mobile web, I'll be talking about the web, because there is no new mobile web. There's no old mobile web. There's just one web. And that's its power. It's the same web, whether it's on mobile or on your desktop or on your Samsung smart fridge, that's literally Android running on a refrigerator, showing Twitter, because that's important. So the power of the web is a platform that's open, that's universal, it's decentralized. There's no single player determining who owns the web and there's no like app store, there's no gatekeeper. You don't have to go to the URL store and like appease Apple to say I want to publish this on the web, or appease Google to say I want to publish this on the web. You can just buy a URL, put things online, and it's yours. It's democratized, it's open, it's wonderful, and it's something worth fighting for. This is an incredibly powerful public resource. So I'm Dan, I work for Mozilla. Mozilla works for the web. And what I mean by that is that Mozilla is actually a nonprofit organization whose mission is to protect, defend, and advocate for the web as a public resource, to try to strike a balance between the private interests on the web and the public interests on the web. And so we do that by building the free and open source web browser Firefox. And we do that so that when some of the world's largest for-profit corporations, Apple, Google, and Microsoft, meet to determine the future of the web, when they discuss things like adding DRM as a standard on the web platform, that we're in that room and that we've earned our place in that room by being a peer and a fellow implementer of the web, but that we're coming at it from a fundamentally different perspective, from the perspective of public good. We're not trying to make a buck off the web. So that's Firefox, that's me. You can find me on Twitter as @Callahan. I've gone ahead and posted a link to the slides and to some other resources. If you're going to have your laptop out, you might as well follow along with something topical. But if you think the web is powerful, if you think this notion of an open publishing platform that anyone can speak on is valuable, is something worthy of fighting for, then you're also probably aware that the web has been under attack over the last 5 years as smartphones get ever more powerful, and more power gets consolidated into two platforms, each with their own walled gardens, each with their own app store, their own ecosystem. And if we want to preserve the virtues of the web, the openness, the decentralization, the universality, the web has to get better. The web has to be able to fight back against apps and deliver a compelling, comparable experience. And what I mean by that is, who here has used Twitter on your phone ever? More or less everyone. Have you ever tapped the Twitter icon on your phone and seen that sort of a message? The internet connection appears to be offline. Try again. No, because that sort of failure is reserved for the web. Apps don't fail like that. Apps fail by saying, oh, I can't load new tweets, but here are the last tweets I had. Oh, I can't post a tweet, but you can at least queue it up and I'll post it when I'm online. And that's why apps have been winning. That's why apps won. They were more reliable, they worked when you're offline, they worked when you're on a bad connection. They were more engaging. When you got a direct message, Twitter could just notify you on your home screen. You didn't have to go and check in with it. And apps were installable. You could give something that you plan to return to a privileged space on your device. So this year that changes for the web. Through standards like Service Worker, Web Push, and App Manifest that Google, Mozilla, Microsoft, and Apple are all collaborating on, we're going to move the web forward and give the web capabilities that let it compete on those same grounds. Let the web deliver an experience that's every bit as reliable, every bit as engaging, and every bit as installable as a native app. Before we go on, I'm going to be showing a lot of JavaScript. Like I said, this talk is related to Python if you use Python on the web, but there's not going to be any Python in the talk. You're going to see some things like arrow functions that are relatively new in JavaScript. They're like lambdas in Python. The signifier is this equal, greater than symbol. And it's just parameters on the left, return value on the right. These two lines are effectively equivalent. The other thing you're going to see a lot of are promises. And you can recognize these by this .then method. Promises are like a chainable version of like concurrent futures or async IO futures like you might find in Python 3. They let you say, go and do this operation, and then when that's done, pass the result to this other callback. And when that's done, pass the result to this other callback. You can keep chaining these things because JavaScript at its core is an asynchronous language. Promises have been baked into the ES6, ES 2015 spec, so they're now kind of the blessed way of handling asynchronicity in JavaScript. This is worthy of your time and attention because they're showing up everywhere in the web platform. Every new spec that has to do anything asynchronous is going to be defined in terms of promises. So you'll see promises in fetch, and service worker, and push, and permissions APIs. You'll see some syntactic sugar, async and await, coming in next year into JavaScript. Worth knowing about. Also, it helps you understand Python 3's futures stuff. That's kind of cool. So the first thing we need to solve is, how do we make the web more reliable? How do we give the web the same sort of resilience to like sitting on the airplane, opening up Twitter, and seeing content instead of seeing an error message? We're going to solve that with service workers, which are a new standard supported in Firefox, Chrome, and Opera, coming soon to Edge, that let you install a script that acts just like a normal script tag, but it's for an entire domain instead of just for a page. So if you think about a JavaScript entry on a web page, if you open a new tab, you get a new instance of that script running. If you close the tab, the script gets killed. A service worker is a JavaScript file that runs independently of your tabs. So you can have one service worker shared between many tabs. You can have one service worker running even when you don't have any tabs open to that domain. And so because this has a different scope, and because it's a very powerful thing, it can run in the background, it can do some really, really pervasive, powerful things to the web, service workers need to be served over a secure connection. So like many new powerful web APIs, service workers require SSL or TLS. In the past, that meant that you had to go shell out money to VeriSign. Mozilla and the EFF have come together to build a certificate authority called Let's Encrypt. You can get completely free security certificates from Let's Encrypt. It's automated, it's fast, it's unlimited, it's amazing. You don't have to choose between your wallet and security anymore. I think we're the third largest CA on the market right now. It's amazing. Supported in every browser. If you don't take anything else away from this talk, like that's worth at least $16.95 a month, or a year. So service workers. The way you turn on a service worker in the browser is you write this JavaScript file, and then you call an API that says navigator.serviceworker.register. And you pass it the URL to the script and a scope. What this is doing is it's saying, I want this file to have dominion over the entire root of my domain, over every page on my domain. And service workers are scoped so that when you're on a page, the most specific service worker gets used. It's the sort of thing that lets you, for instance, build one service worker for the public parts of your site, and then a second service worker that behaves differently, say, for the Django admin. You could have these kind of coexisting. But when you run that, the browser will download the service worker, it'll start running it, and the service worker APIs are all event-based. So inside that file, the first thing it's going to see is an install event, which gives you the opportunity to take interesting actions that make your page more resilient to bad network connectivity. Here we have an event listener where we say, listen for the install event, and then we've got an array of dependencies, so our CSS, our JavaScript, we could have images, whatever else we might need just to get something useful on the screen. And we're going to say, when the service worker gets installed, go and add all of these dependencies to this named cache, my cache v1. It's completely programmatic, it's completely under your control, it's persistent, and these caches are complementary to the browser's implicit caching, like the network caching. You can put things in the cache that the browser has never visited before, you can kind of force it to go and load things, you can load things from other domains. It's all under your control. And so now that we've got something in the cache, what can we do with it? Service workers have the ability to intercept, hijack, modify any request that is originated by a page controlled by that service worker. So I know the text on here isn't legible. That's for if you go and look at the slides later. The important thing are these icons. Normally, when you have an image tag or a script tag or make an XHR request, the browser goes and sends that to the network and then returns that data from the network. With a service worker, the service worker sits right in the middle, just like a transparent proxy. And it can catch that request, and it can choose to look in the cache to respond, it can choose to synthesize a response, or it can choose to forward that response onto the network. It can respond in whatever manner it chooses. An example of that is listening for the fetch event and saying, okay, I want to respond to this fetch by looking inside my caches, trying to match on the event's request. So trying to match on the URL, the headers, et cetera, like the way that this thing was trying to be loaded. And then, if I get a response, return the response. Otherwise, go ahead and forward that request out to the network. Man, this is literally, you could write this code in a service worker and this would perform a useful task. It implement a pattern kind of like this, where you have a request come in, it hits the service worker goes out to the cache. If the cache fails, it then goes and tries the network and returns from there. You can also flip it and try the network first and fall back to the cache if the network's down. This makes sure that users have the most up-to-date information if possible, but it also means you have to wait for the network to time out, which could take a couple minutes if you're on a bad connection. The interesting thing about service worker, in contrast to past standards like app cache, is that service worker is an imperative API. We're giving you a toolbox that lets you build the caching strategy that makes sense for your own application. We're not trying to prescribe how you use it. So an interesting use case could be a hybrid of these two, where you say, I'm going to return whatever's in the cache first. Just give the user something as quickly as possible. But in the background, at the same time, go ahead and forward that request out to the network and see if there's an updated version of that resource. And if there is, put that in the cache for next time. So this is a really useful pattern if you have data that doesn't change frequently or data that it's okay to show if it's slightly stale. Something like a user avatar or a conference schedule. If the PyCon website implemented this sort of a pattern, there would be no need for the guidebook app, at least on Firefox and Chrome. So if we all do this, so the cool thing, like, I'll show you more about this, but you can do this in a way that, like, it is hard to make your site depend on the service worker. So if you're on Firefox or Chrome, you get a better experience. If you're on an iPhone, like, you just have the normal web experience. Like, if you're offline, you get an error, but that's fine, that's the web. And when Apple sees that this is good, fingers crossed, then iPhone users will get the same thing as well. So I want to show you a demo of that. You'll notice that I am completely offline right now. If I go over to Safari and I try to go to pokédex.org, it fails. I'm not connected to the internet. But in Firefox, if I try to go to pokédex.org, it loads. And I can learn about my Bulbasaur. Grass and poison. I don't know what that means. But the important thing here is that if we look at this page, we've got a bunch of links to CSS sprite sheets. We've got completely normal script tags. The HTML has no idea that it's not talking to the network. It has no idea that this request is actually being intercepted by a service worker. So if we go over to the network pane and we reload the page, see that all of these resources came back, and they came back really quick because they're coming from a service worker that's right inside my browser that was installed by this website the first time I visited it. Pokédex.org is super open source. It's like, it goes as far as possible to do things interestingly. It's a good resource to look at. You can look inside the storage and see, cache storage. There are all the sprites that it's loading. It's pre-cached icons. It's got some good stuff. If we did that sort of thing to PyCon.org, which we should, which, like, maybe somebody should sprint on, No need for Guidebook. If anyone's here from Guidebook, I'm sorry, your app has been like a great companion of PyCon for years. Um, but we finally realized that that's a problem with the web that we need to fix. Mozilla also has a website, serviceworke.rs, because we like domains that are clever but hard to pronounce, that has a whole bunch of examples of using service workers for various things. You can actually emulate an Express style like RESTful service or a Flask style service in the service worker and like mock out a backend on the client side. Like there's all sorts of crazy stuff. We've got examples. They're all annotated source code, good to look at. And that's how we make sites work when they're offline. That's how we make sites resilient to bad networks. The second thing are push notifications. When you think about how you use your phone and how you use your computer these days, many of your interactions, or at least many of my interactions, are driven by a notification kind of like that. I'll look at my phone, I'll see something like this is Google Drive saying, hey, I've uploaded this screenshot. It's great, I know that, it tells me I don't have to go into the app to find out if it's done yet. Or hey, your Uber or Lyft driver is here. I want to know that as soon as it happens, and I don't want to have to keep looking at my phone to follow that. Until now, this has been the sole domain of apps installed through app stores, constrained to native platforms. Here are notifications that look absolutely indistinguishable from the native notifications because they are native notifications, but there's a little tiny Chrome logo there. Because these Facebook notifications with images, with subtitles, with links, are coming from facebook.com, from the website, not from the app. And they blend in seamlessly with the native platform. Again, service workers are an evented API, so inside the service worker you can say add an event listener for push, and when you get a push event, you can use a show notification API with a title, with a body, and you get something that looks like this. Hello world, looks like a native notification. And right in the notification you can go ahead and turn off further notifications from the site so you can kind of, if something's annoying, you can revoke permission. And of course, before a site's allowed to do this, you have to grant it permission, just like you would with geolocation, just like you would with using a camera on your laptop. So the way this works, this is again an example from the serviceworke.rs website. We've got a demo that lets you push things. This isn't going to work some offline because there's nowhere to make it to the network. But what you see here is this really big, ugly URL. That's a push endpoint. The way push works is that your browser vendor, Firefox, Chrome, will run a persistent server that acts like a message queue for things that want to be pushed to your browser. Every website that wants to be able to push to you will get a different URL, a unique URL, so they can't correlate across sites. If you want to send data, it has to be encrypted to a public key that's only held by your browser, and which gets, every site gets a different public key, so there's no correlation there either. And generally, if I was online and if you did a curl to this URL, this goes to updates.push.services.mozilla.com, which is a server that's always online. And then the next time my browser connects to the internet, I'll establish a WebSocket connection up there to my vendor's push service. And then that will say, oh, hey, while you are away, please handle these push notifications. And it'll send those down. I can go online and try to do this and see if the conference Wi-Fi is going to be kind to me. Please, please. Oh, I've had issues. Oh, well, you can see ones of these before. If you're offline or if you're on a network that's not reliable like this, it's really helpful to be able to synthesize these events so you can debug them. If you go into About Debugging in Firefox, we'll give you a list of all of the service workers that are registered in your browser. You can click the debug button and get a toolbox that shows you the source code. So here we're going to listen for push events, and then we're going to show a notification. I can set a breakpoint in there. And then I also have a button push that will client side without having to go and transit through this kind of persistent server on the internet. It'll just generate an event locally. Bam, we hit the breakpoint. So if I go and inspect this variable, you can see that I've got an event. It doesn't have any data. It's a push event. resume that. Oh, why are we not seeing the pushes? Oh, they're showing up here. They're just not actually appearing on my screen. Oh, do not disturb. Hey, there we go. So yeah, so we can do that just for kicks. Let's try this. Oh, right, I'm offline again. I swear it works. Yeah, there you go. So right now, if any of you like copy down this URL manually and try to push, it will ping my browser, which is kind of great. So that's super important information. Like knowing that URL gives you the ability to talk to the user's browser, even when all the tabs are closed, even when all the windows are closed. Still pushes. Or pings. Oh, come on. It works, whatever. Live demos. 8080? Yeah, slides. So we'll run through this. I always try to figure out what the right mix is between live demos and tempting fate and just assuring you that it works. You saw it work a couple times, you saw it not work a couple times. I'll talk to you about why later if you want to meet me outside. So yeah, so you can push things. That's great. It lets you re-engage users when you need to. If you got something like an incoming message, or I live in Minnesota, so I would love to get a push notification when I have to move my car because they have to plow the streets. Great uses for this. I'd love to be able to do this just through the web. Of course, you have to ask user permission. This is kind of the API. You say navigator service worker ready. Then, with that service worker call push manager subscribe, that prompts the user. When the user says, okay, I will let push things happen, then you get a subscription. You just want to post that subscription back to your backend, save it in your database associated with the user. It's that big, long, ugly URL I showed you. In the future, when you want to talk to the user, send an HTTP post to that URL. Quick note on compatibility. This works perfectly in Firefox and Chrome, but Google doesn't implement the API in the spec exactly right yet. They're working on it. You have to go and instead like jump through some hoops, register with Google, send an extra header with like an API token. They're working on getting rid of that. Firefox, if you know the URL, you can notify the browser. The last big hurdle is installation. How can you give an app-like experience, an app-like prominence to a web property? And we're going to do that with app manifests. If you think about an HTML document, you've got the head and you've got the body. And the head has metadata about that document. An app manifest is a way to provide metadata that's broader than just a single document, that may encompass many pages. It's just a JSON file. You put it in your head. You say link rel manifest, source manifest.json. And this is the manifest from Flipkart Lite. Flipkart's a competitor to Amazon in India. You can have a name, you can have icons, a start URL. So you can say, if I add this app to my home screen, I want to start on the root URL, the root path, even if I'm adding it from like the About Us page or something else. You can set preferred orientations, landscape or portrait. You can set theme colors, background colors, things that let the experience know how to integrate itself into the broader operating system and look coherent. And then you can set the display property. Standalone means I want this to appear like it's not part of the browser experience. I don't want a URL bar. I don't want back forward buttons. And it lets you create something that's really, really seamless. So this is Flipkart's website. And you can tell it's in Chrome, because they're doing browser detection right now. But you've got a URL bar. It's a normal browser. But if you go up into the menu and choose Add to Home Screen, you get a prompt pre-filled with the name from the manifest, the icon from the manifest. When you go back to your home, the Flipkart icon appears as a peer, side-by-side, indistinguishable from native apps. It has a launch screen, the title bar changes colors to match what was in the manifest, and there's no browser UI at all. So this is a way if you have an experience that is rich, that users want to engage in, that want to be back to, they want to put it on their home screen, the manifest is what will give you the ability to kind of take control over that appearance. We're still trying to figure out exactly what the right workflow is from going from the experience on the web to the experience on, like as an appified kind of native experience. Chrome will actually prompt you. If you have a service worker that works offline and you have an app manifest and you visit the site several times, Chrome will forcibly prompt you, like, do you want to add this to your home screen? It's probably not great, and we're not quite sure what to do on desktop, but we'll get there. That's just the constituent spec. The big thing is that service workers get us to a place where it makes sense to even start thinking about this. So that's kind of it. If we go through these specs, if you implement service workers, if you use push, if you use an app manifest, you can make a web experience that's just as installable, reliable, and engaging as any app from any app store, while still being open, universal, and compatible, just like the web has always been. You can do this today, and people will get a better experience as long as they're using a browser that supports the specs. If they're not, they'll get a standard, normal web experience, which is fine. And with that, I don't have time for questions, but slides and links, I just tweeted them out. You can also go to github.com/callahan/pycon-newweb. I would love to talk to you more and meet you kind of in the back outside the hall. Thank you so much. One bonus note, Google refers to these things as progressive web apps. Search for that term if you want to find related content, it's great, but don't think that you have to implement everything. Like, you can pick and choose. You don't have to be an app. You can have a progressive web site. It's fine. Thanks.